So, okay. I'll be sharing my screen. Let me know when it's visible. Okay. Is the Python notebook visible? Can someone confirm? Okay. Thank you. Uh, yeah. We'll wait for a couple of minutes more in case someone else is about to join. And okay. So hopefully at 7:05 will begin today's session. So okay, good evening everyone. I'm Anay Shembekar and I'll be your TA in conducting this live session for the course Computational Mathematics, which is conducted by NPTEL. As part of this a live interaction session, the idea is that we'll go through some practice problems together, which will cover the concepts that have been already taught in the course. Apart from this, if you have any specific doubts related to the previous week's content, those can also be discussed here. So today we'll be going through some of the some questions related to the week 1 session, week 1 lectures. So if you remember, in the first week we were taught basics about Python. How do we go about installing it using Jupyter Notebook? What is Anaconda and stuff like that. After which we uh, after which we learned about some basic simple mathematical operations within Python as well as conditional operations together, which were used to help us construct an advanced calculator using Python. We also looked into functions. How do we define them? How do we use them? And different data types, particularly list, tuple, sets, and dictionary. And finally, I think we concluded on if else or the conditionals. With that in mind, I'll start this week's practice session. If you have any doubts during any of the questions or solution procedure, just raise a hand or let me know. Okay, some of these questions have been taken from the practice exercises suggested by professor at, at the end of each video lecture. And okay, yeah, the first practice problem is a relatively simple one. It asks us to write a Python code to try to calculate the volume and surface area of a sphere. So as you all know, I think like from basic mathematics, elementary mathematics, we have all learned that the volume of a sphere is basically nothing but 4 by 4 by 3 into pi r cube, whereas surface area surface area of a sphere is given by 4 pi r square. Right. So these are the basic. This is the basic information that we'll need. We'll try to solve most of these questions in a manner which tries to make use of the concepts which have been taught. So, for example, instead of writing out the direct code, what I would like to do is write a function which computes the volume or surface area, provided user given input for the radius. So, if you remember, does anyone remember how we get an input from a user? Okay. So a user would provide an input simply by writing down input of whatever text that we want to display. So here the text that we want to display to the user is the text that here we want to display to the user is basically enter the value of radius of the sphere. Right. So if I run this cell, what do I get? Suppose I enter the value 3, then what do I get? If I look at the variable r, print the variable r, I get 3. Right. But it's important here to note that when we take an input value directly, what we actually are getting is not, say, a float or an integer, but basically a string. So if I now print type of r, you can see that we are obtaining a string here. So were I to do, say, something like r into 2, it should just print 3 and 3 again, right? So here, by writing this particular statement, we have essentially obtained uh, R as an input from the user, but it is in the form of a string. To convert this to a floating point number, we'll just write float of this particular input. So if I now take again R equal to 3 as my input and print R as well as type of R, you can see that our input is now a floating point number. If I do R into 2, it's working correctly. However, were I to say input something like an S, which is a character, right? So it doesn't have a, so it doesn't, it's no longer a number. S is no longer a number. So were I to execute this script, I will run into an, I will run into an error, which basically says that could not convert string into float for the given input S, which was a character. So while we write it here as float of floating point in number of some particular input, it's on our end, it's important that we be careful to only provide a number here. So with that in mind, we'll move to the next part, which involves creating a function for the surface area. So here, what do we see is define this area of sphere of R. So this is how we define a function. We write the we first write the command def provided by space, then the function name and the function argument. So argument acts as an input to the function when we call the function surface area, and this basically I'll write a comment here stating that this function evaluates the surface area of, of a sphere of radius r. So we know that surface area of a sphere is nothing but 4 pi r square. So we need to also obtain the value of pi. So here itself in this cell, I'll write an import. From math, we'll import pi. From the library math, import uh, we import the value of pi, and we just plug it in here. So it's 4 pi r square. This double asterisk mark basically acts as a exponent function, and then we'll return the surface area. Right, so this becomes a simple function to calculate surface area. Right, so if you want to test it, we will write print of r and then print surface area of r. Sorry, surface area of r. So the surface area is basically 113.09 units. And we'll also create another function to calculate volume of the sphere. So we'll define volume R. We'll write a comment. This is a good practice which makes the code readable. This function calculates the volume of a sphere of radius r. Alright, so we know I've already written earlier that we know the simple mathematical formulas. So it's 4 by 3 pi r cube. I just return this value. Alright, so to bring all of this together, I'll just write a output cell with the printf function that we have learned in this week's lecture. So the surface area and volume of a sphere with radius r is given as surface area of r as my first variable and volume of r respectively. So here we have it. Okay, were I to remove any of the cells below, I can just a quick keyboard shortcut to remove like all the cells one by one is just double pressing D. So this is a handy shortcut, and now we essentially have say one for a sphere with unit radius. The surface area is nothing but 4 pi, and the volume is 4 by 3 pi, which is what we see here. Okay, so very simple approach. Another thing we could do here is what we have learned is to limit the number of uh, digits coming after decimal. Suppose we want to limit to only 3 digits after decimal, then we'll write colon of colon, then decimal point 3f. Right. So a very simple example how to look at looking at user inputs, different imports, functions, and so on. Next, another question that we have, the second question that we have for today is to provided an input positive integer n and another integer k less than or equal to n. We want to verify certain properties of combination. So Again, we start off with some user input. We take n as an input, enter the value of integer n, and k also as a user input. Enter the value of integer k. Right. So both of these, as we learned earlier, simply by writing input, we are obtaining we are obtaining data in the type of string. We need to convert it to integer. So the command to do so is simply int of your string input. Okay. So this is a simple way to do this. Now what we need to check is your k value must be always less or equal to n for any of these combinations to be evaluated. So we'll do a quick check of k less than equal to n. If k less than equal to n, we can say that proceed with checking properties, else k cannot be greater than n, and what we'll do is now again obtain enter the value of integer k which is less than n, and here we'll do a printf function. Sorry, which is less than n. Okay, so what have we done here? We are not only taking the user inputs n and k in using the input function and converting them to integers using the int command, but once that is done, we are also moving on to ensure that k always remains less or equal to n. If by chance k is greater than n, then we are prompting the user again. We are telling him what is the value of n, and then we are again asking him to enter a value of k which is less than or equal to n. So were I to run this particular cell, suppose I take n equals 4 and k equals to nothing, is everything looks fine. But were I to flip it the other way around, n is 2, k is 4, I am being told by the code that k cannot be greater than n and n is chosen to be 2. So I need to enter a value of k which is less than n. So suppose I enter 1. Okay, so now we have values for both k and n. We need to once verify what their types are. So I'll just do print k, type of k, print, then we'll again print n and type of n. Right, so you can see that k equals 1, it is an integer, and n equals 2, it is also an integer. So far so good. So we have obtained two positive integers, k and n, and ensured that k remains less or equal to n. And now we need to verify a few properties. So there are two ways to do so. Firstly, you could ask, firstly, we could use the math module to import combination function, which is nothing but from math import com. We could do this and then say variety to write print combo 2 comma 1, which is 2c1, so which is nothing but 2. Variety to write 4c2, which is, it should be 6. So this could be one way to go about it. Another way could be for us to write our own functions for the combination. So we know that the combination function is n nck is nothing but n factorial upon k factorial into n minus k factorial. Right, so we could write our own function which looks something like this and then use that here instead of the comp function. Uh, for now, we'll proceed directly with the comp function. There are similarly a perm function. I think both comp and combination and permutation functions have been covered in the class. How do we import them from math? So we'll look at, say, the property one, which is nothing but nck equals ncn minus k. So I'll write the left hand side. LHS 1 is combo n comma k. RHS 1 is combination of n comma n minus k. And then what we are doing is, if LHS 1 equals RHS 1, print first property verified with both sides have value equaling right. So I have to put the printf here. So I have to run this cell. What should I get? Okay, I'm getting a combination of 2 comma 1 and another again is becoming combination of 2 comma 1. So I think they are coming same. I'll just change the value 6 comma 2. So k is 2, n is 6. I'll comment out this second line. And now when we look at the property 1, we have LHS1 being 6C2 and the RHS1 being 6C4. So both of these basically are equal. If I look at the second property, what does the second property say? K times NCK. So which is K times combination of N comma K. And RHS2 is N times N minus 1 CK minus 1. N times N minus 1 combination K minus 1. And if LHS2 equals RHS2, again I'll do a printf. Second property verified. Both sides have a value equaling LHS2. Right, so the second property is also verified here simply by using the com function and doing the proper multiplication. If you look at the third, if you look at the third property, it equals nck minus 1, sum of nck minus 1 and nck equaling n plus 1ck. So LHS 3 is nck minus 1, so combo n comma k minus 1 and n comma k. And the RHS value, the third property is combination of n plus 1 ck. And if I just look at what they equate to, I'll do a printf and write third property verified. Okay, so uh, pretty simple, straightforward way to solve this question. We start by verifying whether n and k are integers and satisfy the uh, correct correct uh, relation, but which is k less or equal to n. And once that is there, we use the combination function from math module and use that to simply write down LHS and RHS for each of the properties separately and then compare them in the case where they are indeed equal. We just uh, we just print out that the property has been verified with whatever value it has. Okay, hope you guys are able to follow this so far. Do you have any doubts in this or any other doubts related to the?
No, sir.
Thank you. Now we'll be looking at an interesting question which is on complex numbers. So far, what we have learned basically involves either real numbers or integers, and how do you construct a complex number out of the same. So what I'll just write down a couple of things. Suppose I write the statement a equals 1, and if I now want to print the type of a, what do you think? Will it be a float or a int? Okay, I'll just execute the command. You can see that simply writing a equals 1 and printing it, printing out its type, we do not get any float. But were I to add the decimal point after this and then print out the function, print out the type of a, automatically changes to float. Both int and float basically lie on the real number line, but now we want to explore a complex number. So how do we write that? Python comes with an inbuilt multiplier to be added to the imaginary part of the complex number, which is given by j. Suppose I want to write a equals 1j, and now print. It automatically becomes a complex number. So this 1j is nothing but the uh, complex number with along the imaginary axis, which is at uh, which is at the point 0 comma 1 along the imaginary axis on the complex plane. Suppose I wanted to write a number which is say 1 plus 3i, 1 plus 3j in Python. That basically is Again, it will give out a complex number. So, how do you take an input for a complex number? You could write a function. You could take a string from the user and then try to split it. Suppose like I enter a string of the form 1 plus 3j as my user input, and then I want to take this as a complex number. So I will try to do so. So my user input is C is equal to input, enter a complex number in the form A plus A plus IP. So, and I execute this cell. Suppose I enter 1 plus 2j as my input, right? And now were I to write Z, print Z, and look at its type. Try to convert it to, suppose I try to convert it to flow. What will I get? I'll run into an error. Same with int. Can I directly write it as complex? Yes, I can. So this is a very simple way to again take the input, but instead of writing real or integer, we just write complex at the start of it. But we need to ensure that the input exists in a form like this. So I can do say z real plus z imaginary j, something of this form. I'll write an example here. Let's just say 1 plus 2j. Now suppose I want to enter 10 plus 5j. Will there be any errors here? No, everything is fine. So now we have a user input and which is a complex number. I'll just print type of Z again once. And I want to look at some properties, right? Suppose I want to look at the conjugate of this complex number. Uh, okay, there is one library that I don't think has been taught here. Okay, so it's not been here. Right. So my mistake. Sorry. Uh, okay. This complex number has some methods of its own. We can do like say z dot, and then if I press tab on my keyboard, I already see some possible autocomplete options. So which are conjugate, imaginary, and real. So if I write say the real of z, it's nothing but 10. If I print the imaginary part of Z, it should be 5. And if I print the conjugate of Z, conjugate is a function, so you have to put this brackets at the end. You don't need to write anything inside the brackets as function arguments. When you write a complex number and then call the method by placing this decimal point at the end of your complex variable, the method itself takes whatever your input data type was as an input to this conjugate method. So you just have to write z dot conjugate provided by two empty brackets, an empty closed bracket at the end of it. So it will automatically understand, Python will automatically understand that you're asking to calculate the conjugate of z itself. So these are the these are the existing methods for the complex number. And suppose you want to calculate the magnitude of a complex number, you can write define complex magnitude of a z. I'll write the description here of the function. Calculates magnitude, which is nothing but mod of z for provided input complex number z. Right. So magnitude is nothing but z dot real whole square plus z dot imaginary whole square, and we need to take a square root of this whole thing. So we can write sqrt of and print, sorry, return magnitude. Okay, so were I to call this for our provided z, what do we get? It's nothing but 11.18. If we are using SageMath, the answer that we'll get from square root will contain a complex part and it will be a complex number, but the square root in itself is of a sum of two non-negative real numbers, which is the real part of z whole square plus imaginary part of z whole square. We can replace this by, say, from math import sqrt. As we have learned, this function uh, will only work so long as square root takes non-negative input. So now you will see that this is simply a real number. Okay, an important property that we can check here for complex number is z into z conjugate equals mod of z whole square. So how do we write this? We write if, if z into z dot conjugate, this is equal to magnitude of z whole square. Okay, I missed So you can see that when I'm running this code, it's not printing out verified. What might be the reason for this? Anyone has an idea? I'll just print the LHS separately. So say LHS. You can see that LHS is complex variable. And now were I to print RHS, complex magnitude of Z whole square, you can see that it is a floating point number. So we are trying to compare on one end a complex variable with a float. That won't work. So instead, we'll go back to CMath to import the square root function, which will uh, takes outputs a complex number, which means that it can take negative input. So you can see this has changed. Okay. Again, there's a problem with this. Suppose I define a different function without the square root. There's nothing but now you can see that they're both coming out to be same. This is complex magnitude squared of z. So after taking the, it seems like after taking the square root, it seems like what's happening is that a very small error is introduced in the square root value, which causes some problems. However, an interesting thing you can see here is that the type does not matter again, which means to Python, both 125 plus ij, or what I'll write here is 1 plus 0j, is it equal to 1? Is it equal to 1, say 1.0? At the moment it becomes say something like, so there's something interesting happening here. You can see that were I to input a very introduce a very small error into with 1, then suddenly becomes unequal as far as Python goes. This may seem like a small gimmick, but it's very important while we are using Python to do say scientific computation, because a lot of numerical methods that we'll come across whenever you say you take a course in engineering or something, whatever small error that comes across in your numerical method, that might throw off a problem when say you are comparing things like this. So it's important to make note of that and use it properly. Okay, the next question is pretty simple one. Suppose we want to create 10 points in a 3D space of the form XYZ. So I'll write list of range of 0 to 10. I'll write y to be another list of range of say 0 to 20 with a step of 2, and z to be list of chop and 23. If I now print x, y, and z separately, you can see that they have all values like this. And if I print their lengths, all of them are equally sized arrays. With this in mind, x, y, z zip list of zip of x, y, comma z. If I print x, y, z, what do I get? I again get a list where each input is say x1, y1, z1, x2, y2, z2, x3, y3, z3, all the way till x10, y10, z10. So zip command, again we have learned in class, a very quick way to combine different lists together to create an overall list in which each of the input becomes a tuple in itself. So were I to say print the first element, were I to print the first element in XYZ, it will be indexed by 0. In Python, our indexing starts from 0, 0, 0, 10, and now were I to print its by, you can see that this is a tuple. So zip essentially takes three lists or two or three or four lists, and it will just combine them one by one to create say like a tuple with first element, then a tuple with second element, third element, and so on. Now were I to change my x to a different size, say which is list of range of 0 to 5, and then print and then write x1 yz to be equal to list of zip of x1 y z. I just print this up. You can see that because x1 only goes from 0 to 4, which is 0, 1, 2, 3, and 4, the entire zipping operation stops the moment x1 runs out. We can say play around with the size of y and reduce it, and the same thing will happen, which tells us that zip functions for unequal arrays till the point where you have till the point none of the till the point of length of the smallest array involved. Okay, if now we wanted to look at the different say, methods associated with list and tuple, I'll again write a range of say 0 to 10, and I'll print this list. You can see that it contains the entries, integer entries from 0 to 9, and it is a list with length 10. Were I to explore the different methods involved, length of list is simple, straightforward, it is 10. And if I now look at the different methods involved, to find the methods, as we learned earlier, we give a decimal point at the end of the variable, press tab, and then the Jupyter notebook itself will show all the possible methods that can be used to autocomplete. That will be uh, that we can call for type list. So the append function, suppose I include 10 at the end and then print what happens to L. You can see that the number 10 has been added to the end of the list. If I now try to append two members at a time, it will give an error and tell me that list.append only takes one argument, whereas two arguments 10 and 11 were given. So now my list looks something like this. Another can be L.clear. What does this do? It clears my entire list. So now I do not have a list at all. I'll go back to this step and try and print L instead here. So I again have a list from 0 to 9. Then if I were to copy this and then print L1, L1 is the same. Suppose I write a L2 equals L and print L, and if I do dot clear and then print L, you can see that because L2 was equated to L, both of them have been referenced to the same point in memory and both of them contain no data at all. Whereas L1 was written as a copy of L. So once we write an L1 to be a copy of L, L1 takes all the entries associated, all the entries within the list L, and here we have it. So it remains unchanged after that particular point. Moving forward, I'll use the L1 list. And if I wanted to count a particular variable, say 1 within L, there is only 1 appears only one time in L. Were I to write, were I to say append a 1 at the end of L and then print L dot count of 1, I'll also print L of L1. Sorry, list L is empty. Okay. You can see that L1 has been appended to L1 two times. The first time when I put the wrong print count for it, but the second time it's running now, so twice we have appended one. Another function, another method that we can look at is to find, say, the index of 4. So were I to take this as an input and print L of index, L1 of index. So it tells me at what index will I find the entry 4. If I want to find the index where where the value appears in list L1 appears at the first point, it also appears at the 10th and 11th index, but the index function will stop the moment it finds one of these values. I'll also add a few. If I now am to print my list L1, it looks something like this. Another function is the pop function. What does this function do? This function will find find the entry in L1 with index 2, which in our case is the number 2 itself, and it will remove it out from the list. So we end up with we end up with a list without the entry 2. If I do say L1 dot pop of 1, it will return the value 1 as a function. So there are two things happening here in pop. First is it will remove the value in list L1 which has an index 1, which is this value, incidentally the integer 1, but the pop function actually returns that value back. So if I do L1, now my list starts to look like this. There is a different function called as remove. If I give 3 as the input to remove, what it will do is it will find the first instance where the value 3 appears in the list L1 and then remove that value. So the first time 3 appears in list L1 is this value, so this value should be removed using the remove function. Nothing is returned unlike pop function, so my list becomes like this. Another method is L1 dot reverse. Sorry, L is the reverse method. So what this will do is it will just flip around the order of all the entries in the list L1. So you have a list which is 431198765540. Another method associated is sort print L1. So this will sort all the entries in L1, right? So this sorting function works only in the case there are numbers. Were I to include, say, a string or a character A and then run L1 dot sort, I'll run into an error which tells me that the less than function is not supported between strings and integers, which is, I think, self-explanatory. Okay, I think we have covered most, if not all, the methods in L1. Next, I would like to look at a tuple. Tuple is given by, say, 1, 2, 4, 4, 2, something like this. And tuple has a very limited number of methods. It only has rather two methods. T dot count, suppose I do 2 or say 4, will give 2. Were I to find a count of a non-existing member, say which is like 3, 3 doesn't exist in the tuple T given above, then the count will simply return 0. Next function is T dot index. If I want to find the index of the value 4 in this tuple, occurs at second index. So 0th index, first index, second index. If I give a value which doesn't exist, it will give out a value error. Simply saying that 3 or value x is not in tuple, which is the value 3 is not in our tuple. If I were to look at sets, right, and if I just print my set S, right, we have already seen in the class also that any repeated values are no long are not there, and the set returns in a already nice ascending order. You can see that set has a lot of functions. Suppose I write another set S2, which is 1, 3, 5, 5, 6. And if I print the set S2, Again, everything comes back sorted. What do you think happens if we have, say, 1 A, B, A, B, 2, something like this? First, the integers are there, and then the remaining inputs are sorted. Remaining character inputs are sorted. So, again, no repetition when it comes to sets. If I write s dot add, if I write s, again, no change. If I add, try to add, say, 6. 6 gets added to this set. If I do a difference between S and S2, so that should give me the elements in S which are not in S2. So it should be 2 and 4, right? If I do an intersection between S and S2, again, the elements common to both S and S2. If I do whether S is disjoint from, say, S2, it should return false, because S and S2 have some non-zero intersection which you have already seen here. If I were to S2, and if I were to write S3, I'll get a set which is composite of numbers as well as strings. So these are some of the methods which are there for sets, right? And we could also look at dictionary. I think I'll look at the dictionary as part of the next question itself, wherein we are asked to create a nested dictionary with three keys as with three keys as the three subjects, with values of dictionary as the book title, author, publisher, year of publishing. Right. So this is basically a nested dictionary. Nested dictionary. To create the nested dictionary, we'll go in like a bottom to top approach, where we'll first create each of the individual dictionaries and then put them in the overall nested dictionary. So I'll first create the individual dictionaries for subjects. Suppose my first subject is physics. The dictionary for the same I can write on the form of book title, which is say I'm just writing some fictional names. Physics for undergraduate, with an author, say suppose Dr. Jain, something. Publisher, say Siddharth, and my year of publishing is say 2020. Suppose this was my physics textbook. I'll just copy this and create two new dictionaries, changing important. Chemistry textbooks might look like basics and chemistry. Suppose the publishing year is 2022 and the publisher is uh, my third book is basically a say engineering mathematics. So this creates my three individual dictionaries: physics, chemistry, and maths. If I want to see how they look like, it looks like this. So physics has different keys and different values associated with it. I could I'll explore the methods associated with it, but first I'll create the nested dictionary. PCM books. It's basically physics. You can see that the autocomplete shows this variable physics has already been assigned. I press C and then tab. I can already see chemistry. And third is mathematics. Right, so this becomes my nested dictionary called as PCM books. Alright, so we have created a simple nested dictionary, and now we'll look at the different way. We'll now look at the different methods involved. To understand the methods involved, I'll look at this simple dictionary of physics, so not a nested dictionary, and see what all options, what all methods pop up when we are using dictionary. So suppose physics dot keys, it's a function, so we have to put this function brackets, but it's self-referenced, so we do not need to put anything inside the brackets. You can see that I get an output which is called as dict keys, including book title, author, publisher, year of publishing, which is what we have here. Another method, can we say values? It tells me the dictionary values associated with our associated with this values associated with this dictionary. So for book title, the value is physics for undergraduates. For author, the value is Dr. Jain. Publisher is Sri Balaji with the year of publishing 20. One more way to get this is physics dot items. If I write items and execute this, I see something called as dict items, each entry of which is a key followed by its value, another key followed by its value. Right. So were I to say write a list of these things, becomes a nice list, each entry of which is a tuple. To show that, I'll just go back to the physics items, look at the first entry and print out its type. Sorry. List of. So it's basically a tuple. Physics item 0. Another method that we can look at is tab and this. Suppose you want to pop an item. If I do another pop item, if I do another pop item, if I do another pop item, at this point nothing will be there. So the pop item basically in the order of dict items from the last to the first, it will remove each of these items one by one. So we'll go back again to here, get back our original physics dictionary, and if I print physics, it's a shortened dictionary once the pop item has been called. And if I do a clear, then the same thing will happen. So clear will basically remove the will basically clear out all the data in the dictionary physics. Okay, so hopefully these last couple of questions were a bit useful, wherein we looked at all the methods within different data types. Uh, are you guys able to follow this, or is it a bit too difficult? If you have any questions, please either unmute yourself or raise your hand. That way I can know if anyone has any trouble following whatever we have been talking so far. I think everyone is able to follow so far. If not, just raise your hands or type it in the chat box itself. Okay, the next question is the next question asks us to input three real numbers. We want to print the maximum of these values, and then we want to look at the absolute of these values and tell if we can form the sides of a triangle. So we'll start off with user input. Raw input is, or I'll just write it the old fashioned way. A is float off, put off, enter the first number. I can write B is float off, put off, enter the second number. C is float off, input off, enter the third number. Right? This should give us the user input. Suppose the first number is 1, second is 2, third is say 1.2. Right? So next we want to check function to find maximum of these numbers. Define find max of A, B, C. Okay, there are a couple of ways we could do this. The first one is the more uh, prints the maximum value of numbers A, B, C. The first one is like straightforward comparison where you check if A is greater than or equal to B and A is greater than or equal to C. Then you just print A, else if We just combine the else and if together to write elif. So elif will be called if this condition, which is a greater or equal to b and a greater or equal to c, both of these simultaneously are not satisfied. So you could have another case where is b greater or equal to a and b greater or equal to c. You want to print b. Third is c greater or equal to a and c greater or equal to b. So print c. It's a straightforward function and we'll just call this find max of ABC. So it tells us that these are our numbers. Suppose we were looking at different numbers. I now call the find max function again. I find the maximum value to be 100. If I take all three negative numbers, and I run find max again. So a straightforward way. A different way to write this would be to make use of a list. As we have already seen, create a list and sort it to find the maximum value. So my list could be say of the form A, B, C. Then I run the sorting function with associated with the list and simply return the last value of the list. So if I were to write again, I get minus 12. If I play around with the numbers one more time, again I get the same thing. So this is another alternate way to solve the same problem. Whether you use say the top function or the below function might depend on your, it will likely depend on what sort of problem you are trying to solve. So right now when we are running these two functions, it doesn't seem like they take a, either of them takes a lot of time. But if we were to say write a code which calls for this function say 1,000 times, you might find out that both of them take different time, which is where you might be tempted to use one over the other, depending on what resources you have and what constraints do you have for your particular problem. The second part of this problem asks us to check if we can form triangle from these sides. Triangle formation checker. Side A, I'll just write the absolute of the value of A. So the ABS is an inbuilt function which gives us the absolute value of any number. So say absolute value of 1, right? If I write say the if we ask it to calculate absolute value of -10, it will return 10. And whether it can take say like floating point numbers as well. So this absolute value basically gives us a non-zero value. Magnitude of the variable A. Side of B is again given as absolute of the variable B. And side C is again given as absolute of variable C. Sides of the triangle. Possible sides of triangle. Right. And I'll now write angle formation check. function which gives us define is triangle side A, side B, side C. Checks. We can write, but checks if we can form a triangle using given sides. So what do we have? If side of A plus side A plus side B greater than side C, and side B plus side C is greater than side A, and side C side A is greater than side B. If all these three conditions are satisfied simultaneously, then we ask the function to return true, else return false. And now I'll just call this function. So this tells us that we can indeed form a side set triangles A, B, and C. And the way to do so is, if I want to print an output, I'll just use again the printf function, or I could simply call for this function. If this function is to print f, we can form a triangle with sides side A, side B, and side C. So we can indeed form a triangle with these sides 4, 5, and 6. Okay. Uh, Hopefully this is clear. If not, please let me know. We can discuss any of this. Okay. The next question is asks us to create a Gaussian function, which is basically f of x equals 1 over root of 2 pi times sigma or s into exponent of large value. So how do we do this? We again go to our math module. From math, import square root and exponent. If I want to write exponent, you can see that exponent of 1 is e raised to 1, which is nothing but e, which is 2.7182, so on. Then we define Gaussian with x, m, and s as Gaussian evaluated at value x with mean m and standard deviation s. What does this mean? So my function value is nothing but 1 by sqrt of 2 pi. Pi we have already imported earlier, but I'll just write here for completeness. 2 pi into s. This is my first part, 1 over root of 2 pi s. Then I multiply this with exponent of minus zero point 0.5 into x minus m by s whole square. And then I'll return the value f. And if I were to write the output, again I'll use the printf function, which gives us the value of Gaussian with mean m and standard deviation s at evaluated at x is f, as restricted to four numbers after the decimal point, 4 digits after the decimal point. Okay, to write this Gaussian of XMS. Before that, I also have to take user input. That. So m is equal to float of input. Enter the mean of Gaussian. S is equal to float of enter the standard deviation of Gaussian, and x is float of input of enter the value at which we want to evaluate the Gaussian. Okay, so suppose I pick the normal distribution which has a mean of 0, standard deviation 1. I want to calculate again the Gaussian at say x equal to 0 itself. Then when I run this code, I get uh, then once I run this cell, what it does is it evaluates this function Gaussian of xms, where x is 0, m is 0, and s is 1. Were I to play around with say, mean 0, standard deviation 2, and the value 1 changes. If I now suppose change the mean to 2, because Gaussian is symmetric about its mean, if I now change the mean of the Gaussian from 0 to 2, standard deviation I keep the same, and x value I also keep the same. So previously x was 1 unit to the right of mean, now x is 1 unit to the left of mean. We expect the Gaussian to have the same value because of this expression x minus m whole by s whole square. If I now print it again and see that while the mean value has changed, the Gaussian evaluation of the Gaussian itself has remains unchanged. So we could write, say, a Gaussian function. We could write a lot of other functions based on this value. Suppose you wanted to write step function. So if I want to write, say, the step function, define step, uh, we write define the unit step function, which has step change, x. What does this function gives us? This gives us x greater than step change, gives us the value 1, whereas x less than step change gives us the value 0. So it's a simple unit step function, and I want to represent it on my represent it. How would I do so? I would calculate the step change, and I haven't shared this. I have to I have to yeah. The step change function is basic. It remains, this is y-axis, this is my x-axis. Between 0, for x less than step change, everything remains 0. At step change itself, the value becomes 1. Then it remains constant. Okay, so this is how the step change function works. And if I go back to my code now, it looks something like this. If x less than step change, which is a we have return 0, else return. So if I were to call the user input, again, step change is float of input of, enter the step change value for unit step function, and x is float of input of, enter the value where x is a value where unit step is to be evaluated. Suppose my step change is at 10 and I want to find the value at say 5, then my output would look like printf the value of unit step function with step change at x is unit step of step change and x. So from my step function, I expected this value to be 0 if suppose I take the same and evaluate it at 10.1 times. So 0. If I now print the step change function, right? Or if I have both as 10, this is how my unit step function looks like. Okay. The next question we have involves creating a Python program which tells us about the location of a point x comma y on the 2D plane. It should tell us whether the point lies on x axis, y axis origin or a quadrant, and then it should also calculate the distance between a point and the point given point 1 comma minus 1. So we'll first start off with the user input. X is float of input of, enter the x coordinate of point P. Y is float of input of, enter the y coordinate of point P. Right, once I run this, suppose my x is 0, y is also 0, which is my point origin, then we want to write a function to find placement of point P. Define position of point with inputs x comma y. If x equals 0 and y also equals 0, print point P lies on the origin. And if x equals 0 and y is non-zero, then you want to print point P lies on the y-axis. Another condition could be x being non-zero and being being equal to 0. Then you want to print point P lies on the x-axis. Else is else print point P lies inside one of the four quadrants. So were I to run this function, what should I see? I'll see that point P lies on the origin because both x and y coordinates are 0. Suppose x is 0 but y is 1. Then it tells that point P lies on y-axis. Suppose x is 1, y is 0, then it should tell me that point P lies on the x-axis. Finally, if x and y are both non-zero, say 1 minus 1, it tells it lies on one of the four quadrants. Suppose we want to further find which quadrant. Okay, so we'll define one more function. Define quadrant locator of x comma y. We already assume point lies inside one of the four quadrants. So we are not looking at the edge cases, which are origin x and y axis, but directly assuming that the point lies within the quadrant. So if x is greater than 0 and y is also greater than 0, then we want to return 1, or we'll just print point P in lies in the first quadrant. If x greater than 0 and y less than 0, then we'll print point P lies in the fourth quadrant. If x less than 0, so this is second and third quadrant, and y greater than 0, which basically makes it second quadrant. Point P lies in the second quadrant. If x less than 0 and y less than 0, which means that both the point, which means both x and y coordinates are negative, brings it to the third quadrant. Okay, so this is our quadrant locator function, and now we call this inside our position of point P function. So we can do this. We can already define one function previous to defining another function previously, and then call it inside a second function. So for example, for the inputs 1 comma minus 1, we see that point P lies in the fourth quadrant. If I change the inputs to 1 comma 1, we can see that point P should lie in the first quadrant. Okay, so this is a simple example where we combine two functions, and then once that is done, we within each function we put different conditionals, if else, and so on. Okay, once this all is done, we want to define distance metric x comma y. So provided a point, we find distance of point P from 1 comma minus 1. So we write distance to be equal to sqrt of x minus 1 whole square plus y minus 1 whole square. And we do print of this return distance. Suppose I want to further combine this function itself within our position of point P. So I'll define location distance of x comma y. First, I'll call this position of point P function, and then I'll say do a printf the distance of point P given by the coordinates x comma y from the point 1 comma minus 1 is my distance metric function. So now if I want to run this composite function location distance, if I do 1 minus 1, then I expect the distance to be 0, and I expect the point to lie in the fourth quadrant. So what do we get? Point P lies in one of the quadrants, specifically the fourth quadrant, and then the distance of this point from itself should be 0, right? If I were to look at the point 1 1 and then run this location distance of x comma y. Okay, so this is what the value turns out to be. You can see that they are on the same x equal to 1 line, but separated by their y coordinates. Okay, so this is an example of writing different functions and sort of nesting them together to create a composite function which can be called to serve different purposes. Why do this? The idea is that each of these individual functions, whether it is the quadrant locator, whether it is the distance metric or the position of point function, each of these functions are simple in themselves and do exactly one thing. The quadrant, the position function tells us whether point lies on the origin, x-axis, y-axis, or within one of the quadrants. So that's a simple first step. Then depending on that, if the point lies in one of the quadrants, only then we call the quadrant locator function, which tells which of the fourth quadrants, first, second, third, or fourth quadrant. And once that is done, only then we want to find out the distance from our given point, which was 1 minus 1. So this location distance ends up being a composite function and simplifies things. This sort of method where we write functions for only one thing at a time, only one operation, or doing exactly one thing at a time, helps us to minimize errors. So later on when you guys will be doing much more involved examples. So all the examples that I have covered in this session so far, you might think that they're quite straightforward and you would be fair to arrive at that assessment. But later on when you are say working in a job or going into research or doing some advanced course which makes use of all this computational mathematics, you will find that these simple practices of say like printf function and doing creating a function doing only one thing at a time, that's to minimize errors drastically. Okay, I think we're almost out of time, so what we'll do is we'll solve this final problem, which is the practice question number 10. All of us at some point of time, I think in elementary school itself, we have learned about the different temperature scales, Fahrenheit scale, Celsius scale, and I believe most of us would have solved some problems by hand, converting one scale from other. A code like this could be particularly useful. Suppose if in case your computer is connected to a data acquisition system, which in real time obtains certain experimental data, which in this case would simply be your temperature of a particular object, and you want to monitor it and see check what uh, what is the temperature in your particular scale. Suppose your data acquisition system is an old one and only gives you input in terms of Fahrenheit, but all your code, all your computation going forward requires it to be done in the Celsius scale. In such a case, a very simple Python code could be written to address this issue. So we'll write a user input, which is input temperature scale, input, enter the temperature scale for input, F for Fahrenheit, Fahrenheit, and C for Celsius. So suppose we have a input in either Fahrenheit or Celsius, and then I write the input temperature value, which is input, enter the temperature value. Right. So suppose my input is say 65 degrees Fahrenheit. So, so 65 degrees Fahrenheit. Okay. Now I need to convert this into my Celsius scale. So I'll write convert to Celsius, define convert to Celsius, which will take some value in Fahrenheit. What is if you remember the conversion formula from Celsius to Fahrenheit, it is nothing but C equals F minus 32 into 5 by 9. Again, an elementary formula we have all learned in school, and this should just return C. Another function that we'll do is convert to Fahrenheit. Define convert to Fahrenheit. C. F is equal to C into 9 by 5 plus 32. We'll just return. Okay, so these are our two simple conversion functions, and I'll write my output. Printf input scale is I'll also write a composite function which does the conversion, define conversion or temperature conversion to be input temperature scale, and input temperature value. So if my input temperature scale is say Fahrenheit, then I just print my printer the input temperature is whatever is my input temperature value. So input temperature value Fahrenheit. Then I'll do the conversion. So I'll write the output temperature value is convert to Celsius of input temperature value. And then I'll do the printf function again. The converted temperature is output temperature value Celsius. Right. So simple this like bigger function, composite function, basically contains an if else loop. Say, then what we'll do is again we'll do this print the input temperature is input temperature value Celsius, then we'll put temperature value to be convert to Fahrenheit. Then I'll again write the printf function. So converted temperature is output temperature value Fahrenheit. Okay, you'll notice that I've put if instead of else. This is because our input temperature scale can take any string as an input, and I'll also have to modify the input temperature value. But our input temperature scale can take any input, any string as an input. It may not necessarily be F or C. So that is why I'm putting elif, because what this would allow me to do is print a simple statement at the end which states input error in conversion input temperature scale not defined. Okay, so this becomes my simple function, and I'll call it here at the end, the last cell. Okay, so as you can see, there is some problem. We'll rerun this because we have now added this float here that we had missed from earlier. Suppose my input temperature is again 98 degrees Fahrenheit. We expect this to be around 37 degrees Celsius, which is the temperature of human body. I now write this function and I run this. So my input temperature is 98 Fahrenheit, which is converted to 36.667. I'll just limit this to say three digits post the decimal point. This is how it looks like. Suppose I Suppose my input is of the form of Celsius, then if I were to run again this function, 64.4 Celsius. One more thing you can verify by doing a simple hand calculation is that minus 40 Fahrenheit equals minus 40 Celsius. I'm just trying to run that. You can see that I have made a mistake in the input of temperature scale, and as expected, this gives a problem. So Fahrenheit minus 40, it's minus 40 degrees Celsius. And if I just run it the other way around, Celsius minus 40. If I run for the boiling point of water, which is 700 degrees Celsius in Fahrenheit, that should be around 212 Fahrenheit. Now, as I have put, we have put this fail-safe condition here in else. Suppose we write, say, some K 12K at Kelvin, for example. 12K is a very cold temperature, but this, it will tell us that the input temperature scale is not defined. So basically, we again have a simple program converting between Fahrenheit and Celsius scale made out of smaller programs, each to convert to Celsius and convert to Fahrenheit. And then they are called within an if else loop to create a composite function, which also takes care of the edge case where some sort of wrong input data is provided. Okay, I think we are out of time. There are a couple of more questions that I've added here at the end. I've also placed their answers here itself in the Jupyter notebook. I'll be uploading this Jupyter notebook as well as a PDF of the same and a recording of today's lecture within a day or two. So if you want, you can find this and practice some questions of your own, and probably also look at these last two questions that have been added here at them. So that's it for today's class. If you have any questions, you may ask them now, either on any of these practice questions that we have looked at or anything particular which was taught in the lectures. Okay, so I presume that there are no questions uh, because I can't see any hands raised. If you, or you could post them in the chat box as well. If if you have any doubts during running of the course itself, you may post them on the discussion forum as well. We check the discussion forum pretty regularly to try and address any issues that you come up with while uh, while going through the course lectures. And I hope all of you have a system of your own, say a laptop or a desktop computer, where you have been able to install this Jupyter notebook. Okay. Then that's it. I think we'll call it for today. I'll see you again in next Friday, where we'll be going through the week 2 lectures and trying to solve some questions associated with them. If you have any doubts in the meantime, post them on the discussion forum. Thank you for taking out the time, especially today on Republic Day. Uh, yeah, that's all on my end, and I will see you again in the next one. Thank you.